Let's take a look at this next one here, my party people. I want to give you a chance to try this one out. So here's the timer on the screen. And again, I want you to give it a shot in the sense of plug those numbers into the right places, and then we'll go from there. I'm going to give you a full minute and a half to try to plug it in and then actually calculate. But again, no stress, because I'll be here to take care of everything once the timer's up. Give it a shot, and we'll be right back. And that is time. So if you have an answer, feel free to put it in. But at this point, I first want to ask everybody, do you feel like you were confident when it came to just plugging the numbers into the formula? Who felt confident with that? Right on. That's the first step. Again, that's the first step. Before we can see ourselves doing this mentally, before we can see ourselves doing this in less than 10 seconds, we have got to practice the fundamentals first. So let's go ahead and get into it here. We're trying to calculate the slope of the line segment connecting these points on the coordinate plane. So let's go ahead and do it forward here. I'm just going to say this is going to be my x1, y1 right over here. And then I'll just name the second one here x2, y2. Again, just like we said before, the numbers, the 1 and 2, that just represents right here just which ones, which one is our first coordinate, which one is the second coordinate, and that's really it. Here we go. Now that we have it marked, we can go ahead and plug things in, and we can do it backwards and still get the same correct answer. So here we are, my y2, 17. My x2 is 5. So I'll just make sure that I'm consistent by writing each of those numbers first. The y up top and the x on the bottom. Then we subtract. And then we have our y1 and x1 right over here. 5 is the y1 that we'll plug right there. 2 is the x1 that we'll plug down here. And so we'll have 5 and 2. And then once we are sure that we have everything plugged in correctly, then we calculate. So here we are. 17 minus 5, everybody, is what? Yep, that's going to be 12. And then 5 minus 2, that will give us 3. And once we have those, we're good to go. 12 divided by 3, that's going to give us 4, which is answer choice D. And there we are. And there we are. So let's prove the point that this will work backwards before I give you the opportunity to try the next one out. So this is where I'm really going to give you the confidence that, hey, even if you see a negative pop up, it's going to be okay. You'll be absolutely fine. So here we go. Slope, let's do it backwards. Let's go ahead and swap these out. So I will move this over here, move that right there, and move these back over here. So let's do it backwards here. Watch this. So if I did it backwards, let me write my fraction line. And then my y2 and x2 are 5 and 2. So 5 for the y, 2 for the x. Okay. And then from there, put the subtraction. And then we'll go ahead and go over here. My x1 and y1. So my y1 is 17. My x1 is 5. So I have 17 right there and 5 right there. Next up, we're going to go ahead and see what we get. Watch this. Everybody, what is 5 minus 17? I know 17 minus 5 is 12, but what's 5 minus 17? What's 5 minus 17? Yeah, that's a negative 12. So a nice little tip for you if you're struggling with working with negatives. Here's the cool thing. If you're trying to figure out what 5 minus 17 is, well, that's taking the difference. That's 12. But it's going to be negative because you're subtracting more than what you have. So that's the reason why it's going to be a negative 12. Now, if we take a look down here, the difference between 2 and 5, that's going to be 3. But it's going to be a negative 3 because for the same reason, we are subtracting more than what we have. And that's why that will be a negative 3. Now that we're here, we just divide like we did before. 12 divided by 3, that's going to be 4. But then a negative divided by a negative, that is a positive. And so notice, it does not matter which way you go, because as long as you set it up consistently, one of the coordinates x and y values first, then the other coordinates y and x, as long as you do it in that consistent manner, it doesn't matter which one of these you pick as x1, y1, or x2, y2. It does not matter. As long as you plug things in correctly and consistently, you'll get the same answer regardless. One of them might present you with more negatives than the other, for sure. But as long as we practice those fundamentals, we shouldn't be in a position where it feels impossible. My party people, on a scale of 1 to 10, how much would you agree with what I just said? 10 being absolutely agree, 1 being have no idea what you're talking about. Right on. Right on. I'm glad. Now that we understand that fundamental main idea, again, with the formula, all you have to do is plug things in consistently. It doesn't matter which one you pick as x1, y1, or x2, y2. It doesn't matter. We just have to be consistent. If we understand that, then we're lining ourselves up for success. Now, the only things that we have to take into account are potentially negatives and other situations where we might have fractions or decimals. So let's move forward here and let's try one of those out. So let me get the timer up on the screen for you. And let's give it a shot. Again, first things first, just make sure you plug everything in correctly. Then from there, we're going to be working on the calculation.